Hello, thanks for joining us today. We are looking for a senior Flutter developer to help us lead some of our core modules and drive our architectural decisions. To start off, why don't you give me a brief overview of your experience with Flutter and the types of projects you have been leading recently?
Thanks for having me. I have been working with Flutter for about 5 years now, which means I have seen the framework evolve from its early stages to the current ecosystem. In my most recent roles, I have moved beyond just writing features to designing scalable architectures and leading technical direction for entire modules. I have led the development of several enterprise-grade applications, focusing heavily on maintainability and performance. My day-to-day usually involves making decisions on state management, structuring the project for multi-team collaboration, and mentoring junior developers to ensure we are following a consistent design pattern.
That sounds like a great fit for what we need. Let's dive into the technical side. I want to start with some fundamentals just to get a feel for how you explain things. Could you explain the purpose of the build method in a widget?
Sure, the build method is essentially the most critical part of any widget. Its primary purpose is to describe what the user interface should look like at any given moment. Whenever a widget needs to be displayed for the first time, or updated because the state changed, Flutter calls the build method to determine which specific widgets, like text, images, or buttons, should be drawn on the screen. It returns a widget tree, which is a blueprint that Flutter then renders into actual pixels. So if you think of the final UI as a building, the build method is the architectural drawing that tells the framework exactly how to construct the visual layout of that specific part of the app.
Right. And speaking of the UI, Flutter relies heavily on the idea of composing widgets. Can you explain the concept of widget composition and why it's a core philosophy?
Widget composition is basically the Lego approach to UI development. Instead of creating one massive, complex widget with dozens of configuration flags to handle every single edge case, Flutter encourages building complex interfaces by combining small, simple, and single-purpose widgets. For example, if I want a piece of text with some space around it that is clickable, I don't create a custom clickable text widget. Instead, I take a text widget, wrap it in a padding widget for the spacing, and then wrap that whole thing in a gesture detector to make it clickable. This makes the code incredibly reusable and maintainable. If we need to change the padding globally, we just adjust the padding widget without worrying about breaking the internal logic of the text or the click handler.
That makes sense. Now, when we move from static layouts to dynamic ones, we have to choose between stateless widget and stateful widget. When do you decide which one to use?
It really comes down to whether the widget needs to track internal data that changes over time. A stateless widget is used for parts of the UI that are essentially immutable once they are drawn. If the data coming into the widget doesn't change, or if the widget just displays information without needing to trigger its own updates, a stateless widget is the way to go. However, if the UI needs to change dynamically based on user interaction or an incoming data stream, I use a stateful widget. This allows the widget to maintain a state object that can track variables and use the setState method to tell the framework that it needs to rebuild the UI to reflect the new data.
You mentioned the state object in stateful widget. Could you talk a bit about the widget lifecycle and specifically the role of init state?
The widget lifecycle is the sequence of stages a stateful widget goes through, from the moment it is inserted into the tree to the moment it is permanently removed. It is a timeline of events that allows us to hook into specific moments. The initState method is one of the most important hooks because it runs exactly once when the widget is first inserted into the tree. I use initState for one-time initializations. For example, if I need to start an animation controller, initialize a variable based on a passed-in argument, or subscribe to a stream, that is where it happens. It has to happen before the build method is called, because the build method assumes that all the necessary data and controllers are already set up and ready to be displayed.
Let's talk about the developer experience. We all use hot reload and hot restart, but sometimes people confuse the two. Can you explain the difference and, more importantly, when the application state actually resets?
They are both great for productivity, but they work very differently under the hood. Hot Reload injects updated code into the running Dart virtual machine without destroying the current state of the app. If I have a counter at 5 on my screen and I change the color of the text, a Hot Reload will update the color, but the counter will stay at 5. It's perfect for UI tweaks. Hot Restart, on the other hand, is much more aggressive. It destroys the entire app state and restarts the application from the very beginning. This resets all variables and takes you back to the initial screen. You have to use Hot Restart when you make changes to global variables, static fields, or the main function, because those things aren't handled by the incremental updates of a Hot Reload.
Moving into more complex territory, let's talk about state management. For a moderately complex application, how do you handle state to ensure the code stays maintainable?
For a moderately complex app, my main goal is to decouple the business logic from the UI. Relying solely on set state becomes a nightmare as the app grows, because it leads to messy code and unnecessary rebuilds of the entire screen. Instead, I use a state management library like Provider, Riverpod, or Below-C. These tools allow me to move the logic into separate classes. When the data changes, these libraries ensure that only the specific widgets that depend on that data are rebuilt. This not only improves performance, but also makes the code much easier to test, since the business logic is no longer tied to the widget tree. It also solves the problem of prop drilling, where you have to pass a variable through 5 different constructors just to get it to a child widget.
You mentioned Riverpod and Below-C. In your experience, when would you choose Riverpod over Below-C, and what are the trade-offs?
That is a classic architectural debate. Riverpod is generally my choice when I need a flexible, lightweight system that allows me to share state across the app without being strictly tied to the widget tree hierarchy. It is fantastic for medium-sized projects or rapid prototyping because it drastically reduces boilerplate code. You can define a provider and access it anywhere. The trade-off is that because it is so flexible, it can become less structured as the app grows if the team isn't disciplined. Below-C, however, is what I reach for in large-scale enterprise applications. Below-C enforces a very strict separation of concerns using an event-driven stream approach. Every change is an event, and every output is a state. This makes debugging and testing complex business logic much easier because the state transitions are predictable and traceable. The trade-off there is the amount of code. You have to write a lot more boilerplate for even simple features.
Let's talk about the lower-level stuff. If we were to talk about inherited widget, how does it compare to those modern solutions like Provider?
Inherited widget is actually the low-level mechanism that many of these modern libraries are built upon. Its purpose is to pass data down the tree so that any child can access it without manual prop drilling. However, using inherited widget directly is quite cumbersome because it only handles the delivery of data. It doesn't have a built-in way to notify specific widgets to rebuild when that data changes unless you manually trigger a state change in a parent stateful widget, which often leads to rebuilding more of the tree than necessary. Provider is essentially a sophisticated wrapper around inherited widget. It simplifies the API and provides a way to separate the logic from the UI while giving us precise control over which widgets rebuild. While inherited widget is great for static data, Provider is much better for dynamic state in complex apps.
Now let's get into performance. Imagine we have a performance-critical scenario with a very complex widget tree. How would you go about optimizing it?
Optimization in Flutter is all about reducing the number of widgets that rebuild and minimizing the work done during each frame. First, I would implement const constructors everywhere possible. This tells Flutter that the widget will never change, so it can reuse the existing element instead of recreating it. Second, I would localize the state. Instead of rebuilding a whole page, I would use a value listenable builder or a similar tool to rebuild only the specific small piece of the UI that actually needs the update. I also make sure that no expensive calculations, like parsing a large JSON string or filtering a long list, are happening inside the build method, as that runs every time the UI updates. Finally, I would use repaint boundary to isolate complex parts of the UI that update frequently. This prevents the rendering engine from repainting the entire screen when only one small animation is running.
That leads nicely into the rendering pipeline. Can you describe how Flutter actually turns a widget tree into pixels on the screen?
The rendering pipeline is a multi-stage process. It starts with the build phase, where Flutter creates the widget tree based on our code. Then it moves to the layout phase, where the framework calculates the size and position of every element based on constraints passed down from parents. After that is the paint phase, where the framework records how the UI should look. Finally, the compositing phase takes those recordings and sends them to the engine to be rendered by the GPU. What makes Flutter high performance is that it doesn't use native OEM widgets. It uses its own engine, like Impeller or Skia, to draw everything directly on a canvas. By bypassing the communication bridge between the framework and the platform's native UI components, Flutter can consistently hit 60 or 120 frames per second.
You mentioned the layout phase. I've seen a lot of talk about render objects. Could you explain what they are and the painting pipeline?
While widgets are just the blueprints, render objects are the actual engines that do the heavy lifting. They handle the real calculations of sizes and the actual drawing of pixels. The pipeline for a render object involves three main steps. First is layout, where the render object determines its size and position based on constraints. Second is painting, where it uses a painting context to draw itself and its children onto the canvas. Third is composition, where those painted layers are sent to the GPU. This separation is key because it allows Flutter to be efficient. It only updates the specific render objects that have actually changed, rather than rebuilding the entire visual stack from scratch.
If you were tasked with building a highly specialized UI component that couldn't be achieved with standard widgets, would you use custom paint or a custom render object? When is one better than the other?
It depends on whether the complexity is in the drawing or in the layout. I would use custom paint if I just need to draw shapes, lines, or custom graphics, but the size of the widget is already determined by its parent. Custom paint is great for visuals, but it's limited because it relies on the parent for layout. I would implement a custom render object by extending RenderBox if I need precise control over the layout phase itself. For example, if I'm building a custom scrolling effect or a complex grid where children need to be positioned based on logic that standard layout widgets can't handle, I need a render object. In that case, I would override the perform layout method to tell the parent exactly how much space I need, and then override the paint method for the drawing. You also need a render object widget to bridge the gap between the widget tree and the rendering tree.
Interesting. I want to touch on a concept called immunity in the rendering engine. What does that mean in the context of Flutter?
Immunity refers to the ability of certain widgets or render objects to avoid unnecessary rebuilds or repaints, even when their parents are updating. In a standard flow, a build phase triggers a cascade down the tree. However, by using constants and specific optimization techniques, we can make a branch of the UI immune to these changes. The rendering engine recognizes that the properties of that specific element haven't changed, so it simply skips the layout and paint phases for that entire branch. This significantly reduces CPU usage and is one of the primary ways we keep complex apps feeling fluid.
Let's shift gears to asynchronous programming. How does the async await syntax work in Dart, and why is it important for the UI?
The async and await keywords are used to handle operations that take time, like fetching data from a REST API or reading a file, without freezing the main thread. When you mark a function as async, You are telling Dart that the function will return a future, which is basically a promise that a value will be available at some point. The await keyword pauses the execution of that specific function until the future completes. The critical part is that while that specific function is paused, the rest of the app continues to run. The event loop keeps processing other events, so the user doesn't see the UI freeze or lag while we are waiting for a network response.
Speaking of network responses and data, how do you handle dependencies and service locating in a large-scale modular app?
In a modular app, you have to be very careful about prop drilling. I avoid passing services through every constructor. Instead, I use a service locator or a dependency injection framework. A service locator acts as a central registry where I store instances of services, like an API client or a local database helper. For modularity, I group these dependencies into feature-specific containers. This ensures that a particular feature only has access to the services it actually needs. This decoupling is huge for testing. I can easily swap a real API service for a mock version during a unit test without having to change any of the UI code.
You've mentioned modularity a few times. If you were architecting a large-scale Flutter application from scratch to ensure long-term maintainability, how would you structure it?
I would implement a layered architecture, specifically something like clean architecture. I would divide the app into 3 primary layers: the data layer, the domain layer, and the presentation layer. The data layer is responsible for the raw API calls and database persistence. The domain layer is the heart of the app. It contains the business logic and entities and must remain completely independent of any external frameworks. Finally, the presentation layer handles the UI widgets and state management. By separating these, if we decide to switch our database from Hive to ISAR, or change our API from REST to GraphQL, we only touch the data layer, and the UI remains completely unaware of the change. I would also use a feature-first folder structure. Instead of having one giant folder for all controllers and one for all screens, I would have a folder for each feature, and inside that folder, I'd have its own data, domain, and presentation logic.
That's a very robust approach. Let's talk about navigation. How do you handle moving between screens, and what are your thoughts on Navigator 1 versus 2?
In Flutter, the navigator acts like a stack. We push roots onto the stack to go forward and pop them to go back. For simple apps, imperative navigation with Navigator 1 is great because you just call a push method and you're done. But as apps grow, especially when you need deep linking or state restoration, Navigator 1 becomes a liability because the navigation stack is a hidden list that's hard to synchronize with an external state like a URL. Navigator 2 introduces a declarative style. Instead of manually pushing and popping, the navigation stack becomes a reflection of the current app state. You define a list of pages based on a state variable. This makes deep linking seamless because you can map a URL directly to a state, and the navigator automatically builds the correct page stack. State restoration also becomes much easier because you only need to save that state variable rather than recording every single manual transition the user made.
Let's jump back to a practical debugging scenario. If you have an animation that isn't displaying correctly, what are the first 3 things you check in the code?
First, I check the animation controller and its listeners. I need to make sure the controller is actually ticking and that the duration is set correctly. If the controller wasn't started, or if the ticker was accidentally disposed, the animation will just stay frozen. Second, I look at the widget tree to see if the animation is wrapped in an animated builder or an animation listenable. A very common mistake is updating the animation value, but forgetting to trigger a rebuild for the specific widget being animated. Third, I verify the tween. I check the start and end values to make sure they aren't the same, and I verify that the correct tween type is being used. If you use the wrong interpolation, the visual change will either be invisible or it will jump abruptly instead of sliding smoothly.
Last technical question for this set. When is it appropriate to use a value notifier versus a standard change notifier?
I use value notifier when I only need to track and notify listeners about a single value of a specific type. It is a specialized, leaner version of change notifier that handles the value storage and the notification logic automatically whenever that value changes. It's perfect for things like a simple toggle switch or a counter. I use a standard change notifier when the state is more complex. If I have multiple related variables, a list of data, or business logic that requires custom trigger points for updates, change notifier gives me the precision and control I need. Basically, value notifier is for simplicity, and change notifier is for full-scale state management.
This has been a very thorough explanation of your technical approach. I appreciate the depth of your answers. To wrap things up, do you have any questions for us about the team or the specific challenges you'd be tackling here?
I do. I am curious about how your team currently handles the balance between rapid feature delivery and technical debt. Given that you're looking for a senior lead, I'd love to know if there is a current push to refactor existing modules into a more modular architecture, or if the focus is more on scaling the current foundation.
That's a great question. We are actually in the middle of migrating a few monolithic modules into a more feature-first structure, which is exactly why we need someone with your experience in clean architecture. We have a lot of legacy code that needs a strategic eye to be cleaned up without stopping the feature train. We'll be in touch shortly regarding the next steps. Thank you for your time today.
Thank you. I look forward to hearing from you.